All right, ladies, gentlemen, today we're going to go ahead and start our next unit. This unit is going to be a little bit more straightforward, a little bit easier than what we just did with trigonometric identities. Let's get started. The first thing that we want to take a look at are inverse trigonometric functions. The good news is you've already used inverse trig functions before. You used them when you had to solve certain sorts of simple trigonometric equations. Basically sine inverse, also cosine inverse, and tangent inverse are going to end up being our three main inverse trig functions. Now, let's go ahead and just take a moment and review here. When we're talking about the word inverse, what does the word inverse mean? Hopefully you thought a little bit about the word opposite. What about the word function? What does the word function mean? Well, keep in mind that the graph of a function must pass the vertical line test. So I'm going to write pass the VLT, the vertical line test. And so we're going to combine together what we know about inverse functions with what we've learned in trigonometry so far in this course. Let's take a look at an example of inverse functions. In fact, suppose we're talking about, for instance, the function sine, which we know quite a bit about. I'll put sine x right here. And suppose that we start with an angle, and we start with an angle of 30 degrees. Well, if we take 30 degrees and we plug in the 30 for x here, and we do sine of 30, think about your unit circle, your value should be a half. So that's what sine does. Sine takes our angle and it makes it into the trig ratio. This is our trig ratio, or fraction. Now, what is the inverse, or the opposite of sine? Well, the opposite of sine is right up here, and we call that sine inverse. If we take sine inverse, that function here, and suppose we take a half and we plug that in for x, what's sine inverse of x going to be? Well, it turns out that we're going to get our 30 back. And basically, sine and sine inverse are opposites of each other, but there are a few twists and turns that we want to make sure that we understand, because it's not quite as obvious as it may seem. Let's take a look at a little bit more with some terminology. Here are our three main trig functions. We got y equals sine inverse of x. Sometimes, though, instead of sine inverse, you're going to see this, arc sine. I personally like arc sine a little bit better than sine inverse, because arc sine really tells me what I'm looking for. I like arc sine because it means the arc whose sine is x. Let me write that here. Arc whose sine is x. Similarly, if we have y equals cosine inverse x, sometimes you're going to see in place of cosine inverse x, the arc whose cosine is x. Same kind of thing happens with tan inverse and arctan. These are the same thing as are those, as are those. All right, so that's a brief introduction. Let's take a look at now some of the theory behind inverse trig functions. You'll be able to find some of this theory, of course, in our online book. So, here it says definition of a function. A function, of course, must pass the vertical line test to be a function. The graph must pass the vertical line test. And basically every element or member in the domain is paired with exactly one member or element in the range. It says, recall the inverse of a function can be graphed by reflecting points over the y equals x line. And this is something we talked about first semester. Suppose you've got the graph of the sine right here. And suppose this is our line y equals x. If we go ahead and we reflect or we flip this right over that y equals x line, it's going to end up basically looking like this. And what we can say right over here is our original graph was y equals the sine of x. But when we flip it, that changes our graph to the opposite of sine, which is sine inverse. So here we have y equals sine inverse of x. Now, they say, is the reflected graph a function? Well, here's our reflected graph. Does this pass the vertical line test? Well, if you take a vertical line and you draw it through here, the line is going to hit our graph at a bunch of different points. And so what we would say is no, because it fails the vertical line test. Now, in order to create a function, we must limit the domain. If the domain is restricted to a certain interval, then the inverse will be a function. And for sine inverse, it turns out that what we want to do is we want to restrict our domain to be between negative 90 degrees, or negative pi over 2, and positive 90 degrees, pi over 2. Now, what exactly does this mean? Well, here they have us highlight something. They say highlight the restricted domain on the graph above. If we go ahead and we take this sine curve, and if we go ahead and we only take the part of the curve from negative 90 to 90, which is basically this part right here, and if we only reflect that over y equals x, it's going to end up looking like this. Just that little piece of our sine graph. Now, if we get rid of all the rest of it, so we only have it from here to here, then if we run our vertical line test, it'll only hit that little piece of the sine at one place at a time, and the reflected graph will be a function itself. So it says the graph of sine inverse will be a function as long as it has this restricted domain right there. By restricting the domain of each trig function, we can create an inverse trig function. Now, when we do this process of restricting the domain, that has an effect on how we figure out values of inverse trig functions. Let's go ahead and look at this just a little bit more closely. Let's take a look at our sine graph. Here we got y equals sine x. It looks like our regular sine graph. What's our domain for the sine? Think about it. Negative infinity to infinity. It never stops. So negative infinity to positive infinity. What's our range? Well, it goes from negative 1 to 1. Now, what we're going to do, of course, is we're going to go ahead and get rid of all of the parts of the sine graph except for this. So we're going to take this part right here, eliminate the rest, and that's going to be what we're going to reflect over y equals x. And if we do that and we zoom in on it, it's going to basically look like this. Maybe sort of like a little strand of DNA. So we have y equals now the inverse, and the inverse of sine is going to be a function as well. What's the domain? Well, the domain for the inverse is basically going to end up being from negative 1 right over here to positive 1 right over here. Let's go ahead and write that in. Negative 1 to 1. What about the range? What's the range going to be? Well, this does not go from negative infinity to infinity anymore like it did right here. It's going to basically go from negative pi over 2 to positive pi over 2. How do we know? Well, here's negative pi over 2 for the y. Remember, range values are y values. And this top y value right here is going to be positive pi over 2, right there. Now we can do the same kind of thing with cosine and with tangent. And if we do that, we're going to be able to basically get our inverse trig relations to also be functions. And when we do that, what we want to do is keep in mind this, that we got y equals arc sine x. The arc whose sine is x, like we went over at the beginning, which is the same thing as y equals sine inverse of x. Y equals arc cosine x, which is the same thing as y equals cosine inverse of x. Y equals arc tan of x, which is the same thing as y equals tan inverse of x. Here it says, when evaluating an inverse trig function such as arc sine or sine inverse, remember that the arc sine of x is the angle, or if you want to, you can replace the word angle here with the arc whose sine is x. You are determining the angle. Also, you are only to give angles in the restricted ranges for the inverse trig functions. List these ranges below. Well, for sine inverse, the range was from negative pi over 2 to pi over 2. For cosine inverse, it's going to end up being from 0 to pi. And for tan inverse, it's going to be exactly the same as sine inverse right here. So we're going to use this same interval. And for tan inverse, it's going to end up being from negative pi over 2 to pi over 2. And this is what we need to know to do our problems. Let's pause here and we'll take a look at some examples of problems in the next part of the video.